Hello, and today we will be doing AMC8 problems. We are going to be doing problems 22 and 25 from the 2017 AMC8. Let's start with problem 22.
In the right triangle ABC, AC equals 12, BC equals 5, and angle C is a right angle. A semicircle is inscribed in the triangle as shown. What is the radius of the semicircle? So C is 90 degrees, and because this is a right triangle, we know that AB is 13. Now when I first saw this problem, I instantly thought about the semi-perimeter theorem. I think that's what it's called, I don't know. It states that the semi-perimeter of a triangle, S, times the radius of the circle inscribed in that triangle equals to the area of that triangle. So let's use that theorem. But first, we're going to need a full circle inscribed in a triangle. We can easily do that by reflecting this triangle across AC right here. So that will give us two congruent triangles that are just flipped, like a mirror image of each other. So let's draw that. AC is over here, AB is over here, and BC, AEC, another one right here. This, okay, sorry if that corner is a little bit messed up. We'll label that D, and now let's draw the circle. Okay, so now we just need to find the semi-perimeter and the area to find the radius. Because if the semi-perimeter times the radius equals to the area, then the radius equals to the area over the semi-perimeter. AC is 12, AB is 13, so is AD, and BC and CD are 5. So BD must be 10. So first, let's find the semi-perimeter. 10 plus 13 plus 13 is equal to 36. And the semi-perimeter is half of the perimeter. So we divide 36 by 2, and that will give us 18. The area is also easy to find. We have that BD is 10 and AC is 12. Right here and right here. So 12 times 10 divided by 2 will give us 60. Since the radius is the area over the semi-perimeter, we get that the radius of our circle right here, this is the radius. The radius of our circle will be 60 over 18. And that, if we simplify it, will give us 10 over 3. We see over here that 10 over 3 is D, so that is our answer.
Now, let's move on to question 25.
In the figure shown, US and UT are line segments each of length 2, right here. And the measure of angle TUS is 60 degrees. Arcs TR and SR are each 1/6 of a circle with radius 2. What is the area of the region shown? So first, I'm going to draw these circles. And their centers are about here and here. So we're going to draw the radiuses, or radii. And now, we have a good diagram. We know that this is 1/6 of the circle, so it's 60 degrees. So therefore this angle is also 60 degrees. And the same over here. All the angles are 60 degrees. So we have an equilateral triangle with side length of 4 because this radius is 2 and this side length is 2. So now we have this equilateral triangle. Let's find the area of it. To do that, I'm drawing a height, and this height has length 2 root 3. Because this triangle right here is a 30, 60, 90 triangle. So the side opposite the 60 degrees is always times root 3 bigger than the side opposite to the 30 degrees. So we know the height, 2 root 3. We know the base, 4. Base is over here. And now we can find the area, which will be 4 root 3. But we're not done yet. We have to subtract the area of these shapes now. So to do that, we have to find the area of these circles. Each one has radius 2. So each one has an area of 4 pi. Since these sections are 1/6 of the area, we divide by 6, and that'll give us 4 over 3 pi. So now we can find our area. 4 root 3 is the area of the equilateral triangle, and we subtract the area of the 6ths of the circles. So that is our answer. We see that that is B right over here. So B is our answer.